So these are the questions whereby, if let's say I give you a shape and ask you what fraction of it is shaded. This diagram is very simple. The kids will tell you, oh, it's half shaded, right? Then I'll give you another shape like this. Then the children ask, I think it's half. It looks like half, but I'm not sure how to explain that it is half. So calculator cannot do this. The concept and thinking behind this is deeper. So you draw a dotted line like this, and then that's how we show the children that, can you see the white space equals to the yellow space, and that yellow triangle equals to the other yellow triangle number 2, and number 3 equals to number 3, and 4 equals to 4. So if you have one of each, therefore it is half shaded. Yeah. The kids also tell you, I know this is half, but what I like to ask them is, how do you know it is half? How do you know? Okay. Oh, sorry. A parent asked, small gap and big gap is under which topic? It's not a topic, it's a concept. So big gap and small gap range from whole numbers to fractions to decimal to ratio to percentage. Area perimeter, like it can be anything. Yeah, measurement, it goes across topics. So it is a concept, it's an understanding of a big gap and a small gap. Can be a lamppost question, can be a number counting question. Yeah, okay. So that's why I always teach concepts rather than topics. Topic teaching happens in the regular class. Okay, so if I cut this shape now, and I cut this shape now, this is how we explain to the children 1 equals to 1, 2 equals to 2, 3 equals to 3, 4 equals to 4, therefore it is half shade. And when we show them an alternative question that they see during exam, primary 4 level, right? If these two diagonal lines intersect in the midpoint, then we know that PR equals to QS. And we call this the butterfly technique, whereby you can see the yellow and green wing of the butterfly, and the other one is the white winged butterfly. Could you see it? So this kind of question, right, is level 1. Everyone can understand it's half-half. But in reality, the exam questions are not like that. So we move the midpoint away. So at P5, P6, they see butterfly question like this already. Then they say the butterfly wings are not very balanced. But because the concept is that they still sit on the same base, right? And then the height spans across. So same thing for Q and S. It sits on the same base, AB and CD, right? And then the height is actually accumulated to the breadth. A second way of teaching will be we plant the real number into the dimensions of the rectangle, and then we find the actual area of the 4 segment to prove to the children that the area is really half-half. So how to solve this question is that once they understand this is a butterfly equals to the other butterfly like that. So therefore, okay, the colored wing is 200 square centimeters. The white wing butterfly is also 200. So 200 minus 120, the green segment, the green triangle is 80 square centimeters. Okay, we call this a butterfly concept. Do you learn this in the textbook? No, you don't. That's why I'm a math specialist, right? I spend all my time teaching math and research math, and look at what's in the textbook, what's not in the textbook, what's in the exam papers, what's in the PSLE papers, and how we put all the things together and present to you in a math booklet that you don't have to search through 10 school papers to find it. Yeah, we've got them together for you. Okay, this is an old PSLE paper question. It was paper 1, question 15 or question 30. I know it was the last question of a particular section. And every student taught that X equals to Y, and they have the same area. So what fraction of the square ABCD is shaded? Yeah, a lot of students will say half. Yeah, they will say it's half. Yeah, because they thought X is 1/4, then Y is 1/4, so it's half. Okay, let me teach you how to do it, okay? So if I cut this up like that, then you have the area 1, 2, 3, 4. They are all equal size. But if I cut the other side, right, like that, can you see? Now they are equal on the other side. I know the kids probably could see faster than the parents. 1, 2, 3, 4, 5, 6, 7, 8, 9. The bottom cut into 4 equal parts. The top cut into 9 equal parts. Then we will put together, all right, half on the left-hand side, that yellow square is half shaded, right? Half of the half. Then the other side is 4/9 of the half of the top. Okay. Then what happens when we put together, since bottom half and top half of the triangle has equal area, equal concept. This is called equal concept. So the denominator must be 18. So 8/18, and the other one is 9/18. So parents, you hear, equal concept will always be tested. And I can say equal concept is only in fractions. You see, it just happened in area perimeter. And in fact, this whole dimension, right, do not have a length and breadth, no numbers given. They only give you two shaded segments. So then we add them together, okay? And that's the answer, 17. Denominator 36, because the entire square is made out of 18 units at the bottom and 18 units at the top. And so the other concept is total stays the same. It will not be in paper 2 because the concept is too, I can't say the concept is simple. It doesn't require a lot of working. So SEAB very smart. This will not happen in paper 2. It will be in paper 1. And you don't even need a calculator for this. You understand? Okay. This is a 2019 question. I would like to bring to your attention to this question is because I know parents are going to say, hi, this is not so easy. No, it is not easy. I can mark 100 scripts, right? Okay, 50%, no, 60% will answer wrongly. So what they do is, how many squares can be cut out from this whole rectangle piece of paper, right? So 35 divided by 5, I'll get 7 along the length. And then later, 24.6 divided by 5, I'll have 4 squares with a remainder segment over there. So therefore, 7 times 4, we know that there will be 28 pieces. Yeah, you know what children will do? Okay, if the children do this, take big area, 35 times 24.6, and they find small area, and they divide it and score 34 squares on this, your child scores 0 marks. 0 marks on the blue working. Not a single mark will be awarded. Is it shocking to you? You think that it is like, okay, what? My child found area, length times breadth, found length times breadth. This is an example of where our length times breadth don't need already. You learn the formula, but it's not applicable here. You understand? So you need to learn the concept. You need to learn the ideology, the understanding of like, how many can I cut along the length and breadth? And then visually, when you really draw it and see it, you can only cut 28. The excess piece at the side cannot be used. Okay, all right. So what has BlueTree done is that what we do is we are very aware of what the children need to learn from P4, P5, P6. What's the transition and what are the things that they need to learn to reinforce with the children, to remind them on how to work out these questions. Sometimes they're not even on the calculator segment, you see. So you half divide by 5. So we will have to keep reminding them KFC, KFC. Then they'll say, no, teacher, it's not KFC, it's KCF. Okay, good, drill into their head already. So you change and flip. Keep the first fraction, change the symbol, and then you flip the 5 into 1/5. So this is just fun ways of helping them to remember. This is a super popular question, school paper, PSI paper, you always see it. So you must help ensure that your child really master all these things. Okay? This trending 2021. 2020, 2019, okay? They'll ask percentage decrease, percentage increase. Yes. Every year we'll ask. Every year. They're either found in graph or found in some FRP questions. Okay, then they will have one liner, one statement like this, worth 1 mark or 2 marks only. Okay, then next one over here, equal concept. Every year it will appear somewhere. Sometimes obvious, sometimes not obvious. So let me just backtrack this one. Alan, Ben, and Chandra question. This is an equal total concept. Later I show you how to do it, okay? And then they don't have the word equal inside, but it's an equal concept, okay? So this is also an equal fraction concept that your child should have learned in primary 4. And usually the child actually was taught to draw the model. Model drawing is very important in laying foundation. So when this comes about, right? Okay, then the children will be able to draw the rest of the units and say, oh, 11 units is 440, 1 unit is 40, and how many men are at the party. So most of the kids end up putting the denominator the same. You see, if the denominator is the same, then you're trying to say that there's equal men and women. So that is that wrong concept. So we must remind the children that it is numerator made the same. That's why you can see these two parts that's being shaded. Okay, but primary 4 transiting to primary 5, we don't really draw model anymore. So we will have to use techniques that are more efficient to help the children solve it really quickly under 5 minutes. Can draw, but you need to be really fast so that it's efficient, you see. So example, I'll just show you how 4B3B come about. After 3/4 of the boys and 1/3 of the girls left. So in other words, there are 4 boy units, 3 boy units left. Therefore, 1 boy units left at the end. 1/3 of the girls, that means you start off with 3G girls, 1G left the room, 2G is left behind. So then we know that there's equal number of boys and girls remaining at the classroom at the back, right? So therefore, the ending at the back here has to be made into 2G units. So this is how we change the units so quickly before, you know, you cut, then you cut into like so many units. And how are you supposed to like really count accurately? So you can see it's so efficient. That's how 11G becomes 66. Okay, so these are strategies and techniques that you'll teach the children, but it definitely takes time to get used to the style. If you send them to me 3 weeks before PSLE, it's hard to make sure it really worked. But you know, 6 months before PSLE, yes, I can make it work. I can make it like a workable kind of method for your child to learn, so that it's like more efficient in the presentation and all. Let me jump to this question that I wanted to show you on the equal concept that is like obvious but not so obvious, right? Okay, let me show you how this ABC people. Okay, so I said this is a total equal concept, but the word equal is not in the story. But when you see, the logic is Alan's money, right? Okay, wait. Alan's money to Ben and Chandra, followed by Ben's money to Alan and Chandra. Can you see? ABC's name were being repeated, but the pairing is different. So we have to ensure that ABC add up together becomes 12 units. And then when we make them the same, okay, this is what happens. Then we are able to find out the units of A, B, and C. So if anybody works with the earlier ratio, everything in the question will be wrong. After you have derived the 3, 2, and 7, right, we can solve anything that they ask for, be it Alan Ben or Alan Chandra or whatever. Okay, so this is how so-called tricky PSLE question could be, where they wanted to test a concept, but they don't openly tell you that this is the thing, the concept that they literally want to test. Okay, this one, round up or round down. You take a photo because I think you will take a while to understand. Okay, so after the session, you can take a look at what round up and round down. It's all logic. Both questions look similar. Okay, yeah, teacher Joe also listen, then you can tell Elena. Cindy baked 15 cupcakes, then she packed in 4.
Okay, Elena, listen.
The other side is Cindy baked 15 and sell them in boxes of 4. You see, the logic is after I divide them, right, I'll get 3.75. Okay, so if I need to pack them, then 3.75, you see, I need 4 boxes over here because I cannot throw away the rest of the remaining, correct? But on the right side, can you see? 3.75. Frankly, yes, I will pack them to 4 boxes, but the question is how many boxes can she sell? She can't sell 4 because the last box is not filled. The last box only has 3 cupcakes. Every cupcake has 4, 4, 4. The last one has 3. So she can only sell 3 cupcakes, 3 boxes of cupcakes. So it's the same method, but you really need to be very careful. Are they packing for home use or are they packing to sell? Tricky or not? I didn't trick you out. Okay, but you need to be very careful when you're reading questions for the school exams. Okay, next one would be like take a photo of this, parents. Okay, these are all the PSLE tricks because only markers will know all these things. Okay, your PSLE markers. So if it's 1599.6, you see your children use calculator, right? The 0 at the back will disappear. So the first question is minus 1 mark. Okay, and then at the end, if you didn't fill in the answer blank in case 4, but you wrote a word statement, you will get 4 marks. Good news? Okay. Case 3, there's a transfer error, but the child wrote a word statement, will also score 4 marks. Got it? Case 2, the child never write units, so minus half a mark. Okay? All right, so units and everything matters a lot. Strongly encourage your children to write angles referencing because if they don't write, they get lost themselves in the solving. So referencing is much encouraged. Okay, so take note of 3 types of errors: transfer error, computation error, and misinterpretation of the question. Like packing the cupcakes for keeping or packing for selling. It makes a difference. Okay. Okay, so how do I check my work? Do and check, alternative methods, working backwards, and of course check every question got missing units or not. Okay, this is like half a mark. What is NTUC? Take photo NTUC, check numbers, transfer correctly, units there or not, and the calculation errors. Press the calculator twice. Okay, parents, can you stop? Don't tell your kids, I'm going to confiscate your calculator. Because your kids need a lot of practice on it so that they are very fast at typing. Then they can save time. Okay, so step by step, we will get there.